Welcome to qnawire.
In part A, we want to find the gravitational force on a 3 kilogram object at the North Pole of Neptune. So they tell us that the acceleration at the North Pole of Neptune is 11.2 meters per second squared, so the acceleration due to gravity. So to find the force then, all we have to do is say force is mass times acceleration, so ma. Our mass is 3 kilograms. Our acceleration is 11.2. And so when we evaluate that, we should get 33.6 newtons. The back of the book says 33.7 for some reason. I'm not sure why. They might have rounded wrong. But I think it should be 33.6. And then part B, we want to find what the apparent weight is of the object when it's at the equator. So because Neptune is spinning, there'll be a centripetal force acting on the mass there, and so that'll be pushing outward on the object. So the total net acceleration on the object will be a little bit less there. So we can say then our total force is mass times acceleration, and this will be the mass of the object times the gravitational acceleration, and then we'll have subtracting off going the other way, mass of the object times the centripetal acceleration. So we can write that, factor out the m, so we have ag, and then the centripetal acceleration is v squared over r. So we're given the radius of the planet, so we just need to find what v is. So we know that the velocity at the equator should be 2 pi r, the circumference at the equator, divided by the period. So they give us the period as 16 hours. So we want to convert that to seconds, which is 57600 seconds. And then we also want to be converting our radius to meters as well. They give it to us in kilometers. But that gives us everything we need to evaluate this now. So simplify this a little bit more. We have that ag still. And then plugging in this expression for v, we should get 4 pi squared. And then we'll have an r squared divided by r, so just r. And then over t squared. And so now we can plug in all those numbers, and we should get 32.7 newtons. So a little bit less, and definitely a noticeable difference between those two values.